Good morning, all. I think we'll make a start and get this webinar underway. My name is Dirk Phoenix. I'm Chief Executive of CIRIA. Thank you really for joining us today on this joint effort between Buildoffsite and CIRIA. And it's really good to see members from the communities of practice at which CIRIA has initiated over the last few years, including managing construction risk and net zero carbon forum. And also good to see non-members on the webinar. Before I begin, just a few housekeeping points. We are recording it, and we will be sending you a link to the recording and the presentations, and all attendees are in listen-only mode. If you've got any problems with the connection or the audio, just send us a message via the Q&A box, and one of the CIRIA team will join you and help you as soon as possible. There's also plenty of time for Q&As. Do feed them in during the presentations that you'll be seeing. We've got 4 excellent presentations, which I'm sure will be thought-provoking. There's a new feature on Zoom for those who don't know yet. You can qualify a question, you can give it a thumbs up, and that allows us to see what we should have popular questions or the more pressing questions that we would want to put to the presenters who are going to be on the panel, and the chair will put those questions to them at the end. Do share your views and experiences with us. You can see the links and the hashtags there, and I hope you'll really enjoy our webinar this morning. So let's start with a quick overview of who we are for the uninitiated. We've celebrated our 60th anniversary the other year as a not-for-profit member-based organization, and all our raison d'etre is about improving performance in the built environment and construction sectors. As you can see from the slide, we really are in the business of producing good practice guidance, and out of that falls excellent training and obviously webinars like you're going to be witnessing today. And we have a really broad range of members, from transport, infrastructure, asset owners, water utilities, to the top 5 of designing consultancies in the sector, as well as most of the tier 1 contractors, and a very big supply chain, including key stakeholders like government departments, regulators, and suppliers, and academics as well. And the CIRIA model has always been about knowledge transfer, and we noticed that there was a real appetite from specialist practitioners to get involved in particular topic areas, and that's why, having had a track record of producing guidance around risk in construction, CIRIA has set up this practitioners network, really focused on bringing a number of worlds together, in particular construction and the insurance world, and we'll hear from the insurance sector later on this morning, and really trying to again improve the management of risk and performance as a result of that. And we're all about collaboration, and these webinars are testimony to that. What are the outputs? We've put on events such as looking at design risk, managing water damage. Also PII is very much at the center of attention at the moment. And we are today talking about materials, and we'll be talking about materials going forward over the next 12 months, starting with timber, and we'll also be talking about low carbon concrete and low carbon steel. And we've put all the resources we can find, so guidance, regulations, thought leadership articles, in one portal, which you can find on our resource page on the CIRIA website. We also have a debate going on in the LinkedIn space, so you can go to managing construction risk and join that group, and we will be putting some of the questions, if we don't get around to them, on that link page later on. And I want to thank our members who've made this possible, Environment Agency, who I know are on this webinar today, and also the law firm who specializes in this area, Fenchurch Law, and the brokers Marsh. And we're also joined by the members of the Net Zero Carbon community practice today. Very much client-led. It was born out of a real need to make this journey, these pathways to net zero carbon more accessible, easier to navigate for clients and their supply chain. And obviously, we've just had COP27. There is a global imperative for this kind of initiative. But also, if you look at the construction sector, very much active in this space. We've just had the consultation and revision of PASS 2080, which is what we looked at in our first year. And recently, obviously, the publication of the low carbon concrete route map and the setting up of the decarbonisation task force, which CIRIA is an active member of. And this forum will continue in its second year, which we're just about to start, with a number of webinars, as I said, focusing on those low carbon materials. But I also want to highlight a webinar coming up on the 6th of December. Do join us. It's going to focus on some of the real best practice out there already, to highlight some Buildoffsite members like Premier Modular and NG Bailey, the latter just producing UK's first net zero carbon building, the Forge, across its whole life cycle. And you can't miss that if you are a practitioner or a specialist in this field. So I'd really recommend that. And obviously carbon tracking, calculating, there are so many calculators out there. This is really important for clients in the supply chain to get a better understanding of what's going on there. And I've got to pay tribute to our members who set it up last year, National Highways, Environment Agency, BAYS, WSP, Thames Water, and Zero Waste Scotland. And we're hoping to renew and join forces with them again. And one of the advantages of being involved in the forum is that you get to contribute, you get to steer the agenda, you get to speak at webinars, get involved with them, and possibly also help steer the guidance, because I mentioned the decarbonisation task force. Hopefully there'll be some guidance coming out of that to see a way through, which is often a quite crowded and dense market space. So that was my intro. I'm delighted to introduce you to our chair for today, Ken Davey, industry advisor and lead on the Social Infrastructure Hub. He's been an architect for over 40 years. He's had experience of different forms of contract and construction methods, but from 2014, he has been researching and evaluating the benefits of DFMA, offsite or MMC from a tier one contractor perspective. And following on from that, he's been working on offsite training material for the supply chain sustainability school, and he runs workshops for the school, who are one of our members of Buildoffsite. So I'm delighted to pass on the baton to Ken. Over to you, Ken.
Thanks, Dirk. Good morning, everyone. We have a very, very interesting programme set up for you this morning, covering a variety of topics. What I'd like to start with is just a brief overview of Buildoffsite. As you can see, this explains what we are actually doing. The last part of this particular slide is our mission statement, an abridged version. You will actually find a copy of the full version on the Buildoffsite website. We have around 60 members from a wide range of organisations. I think that I was going to say the next slide actually shows that wide range of companies and organisations. I have been engaged recently to take on the running of the Social Infrastructure Hub. Over the past 2 years, the hub activities were seriously curtailed. This actually shows you the different groups. So we have client group and 3 hubs. As I say, I've been given the responsibility of running and managing, or running and managing the Social Infrastructure Hub, looking to increase offsite activities in line with the mission statement. And it's quite a wide-ranging, quite an extensive hub, given the range of sectors that I'm actually looking at. So, given the lack of activity because of obviously certain conditions in the country, we're looking to reinvigorate the hub in 2023. And in the diary so far, we actually have a volumetric modular factory visit on Tuesday, February the 7th. We have a site visit planned to see the new super prison east of York under construction Wednesday, 26th of April. And we're currently planning a visit to a timber frame production facility to see the new production lines, which will be featuring robotics. And that will be in sometime in May or June. So that's what's planned, and hopefully there will be lots of interest within the hub. But it's time to move on and to concentrate on the topic of this morning's webinar. This is our programme for the day. As you'll see, we've got 4 very interesting topics. Each speaker will be doing around 20 minutes. We keep our Q&A session to the end. And our speaker lineup for this morning includes John Wilson from Donaldson Timber, David Miller. As you can see, I won't actually read all the rest of this out. So at this point in time, I think we're ready to go into to ask the first speaker to pick up the reins. And John has considerable experience in the timber frame construction sector, having worked with Donaldson Timber for a long time. So I'd like now to hand over to John Smith. We're on, John.
Yep, there we go.
There we go.
We've got. Hopefully you can see and hear me now. Thank you, Ken, and thank you, Dirk, for the invitation. So let's crack on and have a look through the slides. So thank you. My name's John Smith. I'm Technical Director at Donaldson Timber Systems. We formerly known, some people in the call may have known us as Stuart Milne Timber Systems. We were part of Stuart Milne Group until December last year, and then the business transferred over to new ownership with the Donaldson Group. So a little bit of background of where we were, and then I'll touch into the residential sector and some overview of timber frame. We've been around for 47 years, design, manufacturing and site installing of timber frame across the UK. We work with a range of the sort of national, regional and local house builders and primarily the private and affordable housing sector. And I'll touch on some of the other tenures as I go through this morning. We cover UK-wide supply, and I say over a range of products developed over the last 47 years of proven solutions for the offsite sector. And currently, we manufacture and supply around 9,000 units a year, a unit being a house or an apartment, if you like, and investment to grow that as well over the next 5 years, up to around 50,000 units with some of the innovation and advancements in our factories. As I say, UK-wide, we've got 2 main hubs, if you like, where we have our factories and back of house operations, and one in Aberdeen, where the company was founded, where we have the factory and our design and back of house procurement, HR, finance support teams. We have another factory in Whitney, which is now our sort of head office. Whitney, just outside Oxford. Again, similar set up with a factory and full support team in there. And our newest addition to the business was a spoke, if you like, in Falkirk. That's a manufacturing centre only, supported from the 2 main offices. As I say, in a manufacturing centre local to where the work is and where we are. And we currently also have 2 regional offices, one in Glasgow and one in Milton Keynes, which are office locations only, where we have local business development, operations team, design teams and the like spread around the country. The 2 grey dots on the map there, one in the northwest, one in the southeast, essentially are the locations identified as our proposals over the next 5 years to grow capacity, is to open another couple of spokes where we can open up sort of fairly quickly some manufacturing facilities close to where the volume of work is likely to be. So they don't exist yet, but that's the plan, and how we, along with the investment in the factory, how we grow capacity. So a little bit about timber frame and what that is and what we've been doing for the last number of years. Essentially, manufactured in factories across the UK as an industry. We've probably got quite a wide range of factories, from sort of fairly low entry startup manual operation with saws and benches and people with nail guns and the like, manufacturing very good quality timber frame, right up to probably where we sit at the end of the scale, where we've got automation, fully automated lines manufacturing timber frame panels and floors. And the system essentially is if I run through sort of from top to bottom on the images there. Open panel walls are the sort of mainstay of the timber frame market at the moment, probably, and certainly have been for all the years we've been in it. Essentially, stud frame walls manufactured in panels, delivered to site flat pack as the structural element of the building, with openings preformed for doors and windows and the like. More now, as we start to evolve and as regulations become more onerous and things we need to do, start moving into closed panel external walls and becoming more common. Again, the same open panel, but with factory applied insulation, factory applied internal sheathing boards and service zones, and options for things like pre-fitted windows. There are companies who then take that to the next stage as well. It's essentially still timber frame and put some cladding on the outside of the walls, service conduit, plasterboard, and internal the walls. Floors generally using traditional timber I-joist, engineered timber, or less so now solid timber. Floor cassettes, but again manufactured into large cassettes in the factory rather than supplied as traditionally would be to site. And then roofs, essentially for the whole structure, using traditional roof trusses, spandrel panels to form the roofs for a normal cold roof, as you would see on any other form of construction. But generally nowadays, in timber frame, roofs are assembled at ground level, minimising manual handling, minimising working at height. We assemble the roof at ground level and then use cranes on site to then install that and lift that into the final position on top of the completed building. And on some of the more commercial type buildings, be that schools, hospital, hotels that we sometimes do, or even indeed for 2.5-storey housing, which is quite common, we do an insulated roof cassette as part of the timber frame package. As I said, all of that installed on site with the use of a crane, and typically on a sort of 4-bed typical detached house in the UK with the roof pre-assembled on site. Generally, that's a 1-day installation for the structure of the building to get to pretty much, if it's closed panel windows, to a weather-tight stage in 1 day with a crane on site to build the unit. Compared to what you'd normally see in a masonry build, that would probably be 6 or 7 weeks to get to that weather-tight stage. The tenures that we work in across the construction industry, say timber frame, quite commonly used and has been in hotels, student accommodation type residential buildings, low-rise hospital, healthcare facilities, generally single-storey, sometimes 2-storey buildings, schools and colleges as well, quite common and suitable for timber frame. But the main part of the market, and certainly the main part that we as Donaldson Timber Systems are involved in, is essentially allowing low-rise housing and low to medium-rise apartments. Generally focused on apartments at 4-storey and below. We can and do up to essentially 6-storey. So we're at that below 18-metre height for timber frame. To be practical, as a pure timber frame, there are other timber solutions that some other people are going to talk about this morning around mass timber and CLT, the like, that can go above that. But for our focus, timber frame, as I say, on certainly below 18 metres, and the mainstay of the market is on housing and apartments. In terms of the use of timber frame, I think as most people are probably aware, across the developed world, it's kind of the more common use of construction in Scandinavia, America, Canada, Australia, New Zealand, and the like. It's certainly the most common form of construction in various guises and prefabricated panels, as we do in the UK, to sometimes stick build on site and formed on site, but it's certainly quite common at home here in the UK. Certainly the preferred build method for most self-build customers when they build their own house. And indeed in Scotland, where timber frame is certainly the standard approach for new build housing, and is about 90% of the market share in Scotland of new build houses is done in timber frame. And in terms of current volume, where we are, we're currently, if you look at sort of pre-pandemic levels as the benchmark in 2019, we were up at around sort of 58,000 timber frame units built in the UK. So that from a total that year of around 215,000 new housing starts, I think we're probably sitting about a 27% market share across the whole UK. Scotland, as I said earlier, is a fairly steady market with about 90% of the new houses built, they are in timber frame. The growing market is in England as more and more builders transition over to that for a multitude of reasons that we'll touch on as we go through, and that's certainly growing up. And that's steadily growing from even just in 2016, at around 46,000 units, was about 25% market share, and continue to grow. And then starting a trend again as we recover from the lockdown of the pandemic, housing starts to continue, we see that market share continuing to grow. In terms of who we work with, moreover, the wider market, these are the customers that we all work with, the supply timber frame. As I said earlier, a range of some of the national house builders, regional house builders, and local companies as well, in both the private and social market. I think more interestingly for this, however, over the last number of years, a number of our customers that are on the screen there have invested in their own timber frame manufacturing facilities. So we started the journey with Barratt's back in 2014 to really get into volume timber frame. We worked with them for 5 years on that, and in 2019 they bought their own timber frame company in the central belt borders of Scotland and Oregon. They've done that for the last 2 years, and only earlier this year have released and announced that they're well through manufacturing, building a new factory themselves to increase further capacity in timber frame within Barratt's. We still work with Barratt's and still supply a lot of their volume, and will continue to do so, but they're investing in it. Similarly, Miller Homes in Scotland, almost exactly a year ago, November last year, purchased a timber frame manufacturer. And again, in the last couple of months, Avant Homes have done similar. So some of the builders that we're working with are all looking at that as they work with us and other timber frame suppliers, but they're starting to invest in that as well. And I think most encouragingly, just in the last number of weeks, Vistry partnerships and their acquisition of Countryside. Countryside again are a provider, a housing provider. They have their own timber frame facilities, and they had a facility in Bardon that they weren't going to take forward. Quite good news in the last couple of weeks that Vistry, through that partnership, have picked up that and confirmed that they're going to open that factory up, and again add further capacity in the timber frame market over the next couple of years within their own new group. So I think that sort of sets the scene of where we are with timber frame and the market. I think the use of timber and to touch on carbon, the use of timber in the built environment is absolutely key, and key to the UK's net zero targets and journey. I think the first key next step in that is the Future Home Standard. So coming into force in 2025, the Future Home Standard, with a target of reducing the carbon emissions from new build housing by around 75%. Where we are now then, so that's due 2025. The consultation on the final details of the Future Home Standard is due in the spring 2023. We as industry, as timber frame and masonry and other supply chains, are working with the Future Homes Hub right now on what that consultation will look like. But essentially that timeline is pretty much set, with consultation in spring 23, legislation in 2024. So all new houses from 2025, mid-2025, will start and need to comply with those targets of the Future Home Standard. Key factors in the standard, as I mentioned, overall target is to reduce carbon emissions by 75%, and within there are kind of three measures. So there's the primary energy measure, which is the whichever fuel is used to generate the power, be that oil, gas, wind, or whatever, and that applies a fuel factor to how then the emissions are targeted. A measure on carbon emissions, which have always kind of been the measure that's been used through building regs for compliance with the requirements, as essentially as it suggests, that's the emissions from the fuel used to operate the home for heating and hot water and power. And thankfully, I think we've been lobbying for a while the introduction of FEES, the Fabric Energy Efficiency Standard, which is essentially setting a minimum standard for a high-performing fabric. So it stops the temptation to just replace energy and make green energy and still build lesser quality homes. The FEES standard essentially drives in a better standard. For the technical people on the call, there's some target performance values there. Those are likely to be the kind of levels we're looking at, but not defined yet. That'll be part of the consultation. And I think also importantly in there, and certainly for timber and timber frame, the introduction of the Building Regulations Part L report, essentially a two-stage process that's now in place under Part L 2022, is two-stage checks that the design stage will comply with the requirements, but more importantly, an as-built evidence target, which essentially will include photographic evidence of key thermal junctions to make sure that the as-built performance achieves what the design intent has been. And again, it's another critical step to make sure that there's no gap between design intent and as-built performance. As I touched on, the Fabric Energy Efficiency Standards, or FEES, why is that important? As I mentioned, I think really key because the target is to reduce the need for energy rather than just using low carbon energy efficiency. If we can take away the need for that by building better fabric, better thermally insulated houses, then that's a benefit. But also with the very likely change of getting rid of things like gas boilers and introduction of things like air source heat pumps, all these sort of low carbon heat pumps like air source, they're essentially a low grade heat. So you won't be able to leave the house over a weekend with no heating on, and when you come in the door, turn radiators on and heat the house up quickly. These things like air source heat pumps, anybody who's got underfloor heating will be the same. You need to keep the house at a fairly consistent temperature. So for them to be efficient, they need to be used in conjunction with a high performing fabric. And then moving on, embodied carbon, a very, very brief overview of what that is. Essentially, embodied carbon is the measure of all the carbon emissions, essentially for two stages, from cradle to completion, right from the extraction of raw materials. So be that, mining ore to make steel, to cutting down trees for timber, all the way through to the construction and all the carbon emissions associated with transport and manufacture of products. But also at the end of life, at the end of the asset use, be that the house or the building, in terms of a measure of the carbon emissions from demolition and disposal of the materials at the end of life. Embodied carbon, I think, is key. It's not included as a measure in the future home standard. And I think that we'll touch on as a kind of key thing to consider and make sure that we don't have any unintended consequence. Also included in the benefit of timber is carbon, what's called carbon sequestration. So essentially, very clearly, when trees grow, they absorb carbon dioxide from the atmosphere, turn the oxygen into fuel to grow the tree, and emit the oxygen and convert the carbon, into fuel. That carbon is then stored within the timber. So very, very roughly, for every cubic meter of timber that's in existence, and whether it be structural timber or any other use, it stores about a ton of carbon within that timber, and that's stored for the whole life of that timber. And it holds it in there. And a typical new build detached home built to 2021 standards, whole life carbon, so that's the operational carbon of the home in terms of the 60 or 100 year life of the home for heating and power and maintenance, but also the embodied carbon from cradle to grave, typically is around 200 tonnes of carbon for the life of that home. Of that 200, 165 tonnes are the in-use energy, and 35 are the embodied carbon for the construction and disposal stage. the point of embodied carbon not being included, going back to the future home standard I talked about, the target is 75% reduction of the operational carbon. So the 165 tonnes of operational carbon in the building, if we achieve everything that's in the future home standard, we reduce that by 75%, that 165 tonnes becomes 40. However, that 35 tonnes of embodied carbon isn't measured, therefore still exists. So actually, if we do everything in the future home standard and build a home with the same embodied carbon, we're actually only getting to about 75 tonnes of emissions. We're only getting about a 60% reduction. And I think more importantly, as we go through building to achieve the fee standard and the better buildings, quality of buildings that we need for the future home standard, there is a real risk that because embodied carbon isn't measured, that actually we could end up with industry building homes using much more insulation products, much more unenvironmentally friendly insulation products, because they'll achieve the required standard, but actually there's a real risk that the embodied carbon will increase as opposed to stay the same or get better. So from that perspective, we're working hard to ensure that the embodied carbon should be measured and included to make sure there's no unintended consequence of not actually achieving our targets. In terms of timber frame, again, based on 2021 building standards, so what we're building today and for the last number of years, a typical sort of 3-bed end terrace house as an example, just measuring embodied carbon from cradle to completion, a timber frame house saves about 2.5 tonnes of carbon compared to the same masonry house. That being the same masonry house, but into the same energy standard and the same performance. If we include the benefit of carbon sequestration and we can recycle material at the end of life, that saving jumps up to about 6.5 tonnes, and there's actually a negative carbon. There's more carbon stored in that timber in terms of than there is used of embodied carbon for the masonry. So it's 6.7 tonnes of carbon in a typical house. If we can get to the stage of building the UK's target of 300,000 homes, 50% of those were timber frame, we would take 1 million tonnes of carbon, of embodied carbon, out of the atmosphere every year just by converting houses out to timber frame, let alone the operational carbon that the future home standard will also add. Couple of other bits to close off, I think, that are relevant for timber and certainly in the residential sector. Pre-manufactured value. A number of people are looking now and looking to build more advanced products and MMC and modern methods of construction. Homes England, for example, have set a target for all the houses on their land. A minimum 25% of houses built on Homes England land should achieve what's called 55% pre-manufactured value. Essentially, that's a calculation of how much of the gross construction cost to build that home is delivered through pre-manufactured products. Be that a prefabricated stair flight, be that timber frame, be that at the full end, a volumetric type building. Essentially, that 55% target can be achieved through a closed panel timber frame with a pre-fitted window and probably a sort of prefabricated foundation system, like a new span type floor. That'll achieve between 56 and 58% pre-manufactured value. And again, that becomes quite important in terms of moving on to MMC. And as we progress through all these things, as I said, we've got a drive for more modern methods of construction. We've got a drive, rightly, for having more better performing buildings and more insulated buildings. I think rightly we're going to have more and more new products coming to market, new innovations coming to market. I think the real important part is that as an industry, as a house building industry for sure, certainly we've got lots of very good quality controls and checkpoints in place, but they are currently very focused on the current method of building, traditional build on site, where you can build something, somebody can come to site and check it, and then you can go to the next stage. That's just not the case with certain levels of off-site construction as we run through. And this is where things like the third-party certification that we have on the screen there is all the things that we have within Donaldson's. These become absolutely critical, not just to give, in terms of a certification process for customers and verifiers of the right product, more so for lenders, insurers, that actually the products that does what it says, it's going to do what it says in the tin. And part of Buildoffsite, certainly BOPAS, we were an early adopter of that back in 2013, 2014 with the first BOPAS scheme, and now BOPAS Plus. That's been instrumental in the development of our Sigma 2 closed panel system, where we get the benefit of giving people surety that that product's going to do what it needs to do.
I think that's your last. Oh, I was thinking that was your last slide, John, as we've just run over a couple of minutes.
Yeah, just
yep.
Yeah, one very quick. I'll close off on this one, Ken. I'll hand back. Yeah, I suppose where we are, I think out of this one bit I did want to pull out. We were already doing a number of large scale projects in timber frame at that future home standard. We built the Commonwealth Games Village in Glasgow in 2014 with timber. 700 houses, again built to zero, essentially the zero carbon measures in the future home standard, Vista Rico Town, etc. in there. I think we've got that in there and the benefit of timber coming. And the last point for me was, I think timber and residential is the sector. Timber is the only real renewable volume building material, and I think with everything that's coming at us, then I think there's a real opportunity for us to grow and move on.
That's great. Thanks very much.
Thank you.
Yeah,
Thank you.
Yeah, we've got some questions already coming in. Somewhat remiss of me, I forgot to say that John's bio is actually posted in the chat box as a follow-up, obviously with just a brief introduction this morning. Some fascinating figures on the carbon reduction in comparison with other methods of construction, and I think the maximum you can do in terms of PFV is something like 85%, but that's full. I think that's full modular volumetric.
Yes. Yeah.
Okay. Thanks very much, John.
Thank
you. What I'd like to do now is introduce our second speaker. We have this morning David Miller from David Miller Architects. David has worked at the highest level of design, both in the UK and abroad, and is passionate about progressive architecture and emerging technology. Design and delivery excellence. A more extensive bio can be viewed in the chat box, and David's going to speak to us, as you can see, about mass engineered timber. So over to you, David.
Thanks, Ken. I'd like to share our experience of working with mass engineered timber. So perhaps to start, we could define what that is. So in effect, mass engineered timber is created by laying up layers or laminas of timber, most often fast-grown sustainable softwood, to create large structural elements that have exceptional strength. So there are various ways of fixing these layers together. They can be bonded with adhesives or mechanically fastened. The systems that we're most familiar with in the UK is cross-laminated timber, and that's what I'm going to talk about mainly in this talk, which is bonded using sustainable glue under very high pressure. Mass timber has enjoyed an increasing popularity over the past decade, due mainly to growing concerns around the sustainability of building materials and an increased interest in prefabrication and off-site construction, which this technology is particularly well suited to. So in this talk, I want to highlight the advantages and disadvantages of the technology and give you an insight from a designer's point of view on the design, fabrication and construction of a mass engineered timber building. So really the starting point for us is, why do designers like this technology so much? There has to be more to it than it being sort of tactile. And this is actually an old photograph I found in the office of a couple of members of staff stroking a piece of CLT. But the product, the real value of the product is that it's engineered for a very high strength, which makes it a realistic and practical alternative to carbon-intensive alternatives such as concrete and steel. Furthermore, because it's significantly lighter in weight, it reduces loads on the substructure, which again results in less concrete being used in the foundations, again with a knock-on carbon positive effect. In addition to its practical advantages, mass timber presents the opportunity to express the structure and the materials that the building's made of. The idea of truth to materials runs deep in architectural training and theory, and it's very attractive to designers. So obviously the key driver must be sustainability. With 11% of global CO2 emissions being directly attributable to the construction of buildings, and 23% being as a consequence of the production of concrete, steel and aluminium, timber-based technology, with its potential to sequester carbon in its production, has to present a viable future alternative in construction. So let's have a look at the advantages. So firstly, as already discussed, it's a viable low carbon alternative to concrete and steel. The managed production of the raw material sequesters carbon during its growth. The off-site prefabrication process gives the opportunity to take the frame of the building off the critical path of a construction project, which can reduce the time on site and associated costs and prelims. Again, the factory-based prefabrication process creates a product with very high tolerances, which has many positive knock-on effects further into the construction, and I hope to be able to show you some of those further on. The on-site phase, as well as being much shorter, creates less noise and dust, which is particularly advantageous on occupied sites or sites in tight urban locations. And the tight tolerances and solid panel construction gives us a very good air tightness in the finished building. In addition, the thermal qualities of the material help reduce thermal bridging issues, making robust details much easier to achieve. The dry construction method also leads to reduced moisture on the site. And there's a confidence in the dimensional accuracy, which allows doors and windows to be ordered in advance and brought to site just in time, rather than waiting for construction to progress to measure up before ordering. And finally, the accurate prefabrication reduces waste on site, and the unused timber in the factory is recycled. So that's the good news. What about the disadvantages? So firstly, it's a comparatively new form of construction in the UK, which can generate a nervousness and a resistance to its adoption. Detailed design needs to be completed much earlier. Late changes are more difficult to accommodate, which brings the effort curve further forwards in the design process. We would argue that this is not necessarily a bad thing, and with the imminent changes to the construction environment as a consequence of the Building Safety Act, is a situation that the industry needs to adapt to anyway. From a design point of view, specialist input, whether through early contractor involvement or the appointment of specialist consultants, is required early in the design phase to ensure that the design is right first time. The building technique is less flexible and adaptable once built, so any future fit ideas need to be considered in advance and built into the design. And the system requires external insulation and cladding, but it does form a very robust background without voids for external wall systems to be fixed to. Another issue is, although the engineered timber is kiln dried, the timber is still a natural material, and stability and movement of the frame needs to be considered and factored into the design. It's much more mobile than more traditional methods of construction, and I think this highlights the need to work with specialists early in the process. Because of the off-site fabrication and the early decision-making, robust structural and services coordination needs to be carried out in a very timely manner. although late alterations are fairly easy to make to a timber panel, certainly more than a concrete wall, it's still not an ideal situation. A major disadvantage at the moment is that all of the suppliers are still overseas. So the product requires importing and transportation. This obviously introduces exchange rate risks and means that the carbon costs for the transportation have to be factored in, which dilutes some of the carbon benefits. Craneage is obviously required, which isn't unusual for a construction site, but it's more likely to be a temporary mobile crane requiring access needs to be considered fairly early in the construction. And finally, the material costs can appear quite high in comparison to other materials on a simple like-for-like basis. So when evaluating cost, it's necessary to factor in reduced substructure costs and the potential time savings on site and the implications that would have on the prelims. So I'd like to consider why mass engineering timber works so well with digital design and construction, which has obviously lots of other positive knock-on effects for the process. So to do this, I'd like to follow a specific project through the design, fabrication and construction on site. The project we're using is a school project called Mayfield, which is a new secondary school built in East London and completed about 8 years ago. Mayfield was a DFE funded school, which for various reasons had to be designed and constructed within 18 months, including the planning application and all stakeholder engagement. So it was a very fast project. We don't think that this would have been possible without bringing together digital design techniques and off-site construction. And it was a very early decision to look at cross-laminated timber for its construction. And really the key element here is the need for a rules-based design from the outset. So as well as talking about off-site construction, this is really a call for platform design. So in this project, what we were able to do was adapt our already existing client-specific digital kit of parts, which had been evolved and refined over a number of previous school projects, and then absorb into that a rule set given to us by the specialist engineer. This ensured that we were designing within the limitations of the CLT frame. At this point, there were no specialist suppliers in mind, so the rule set was broad enough to be adaptable to the potential fabricators in the marketplace. So again, this relied very heavily on the input of the specialist engineer, who was, in this case, Ramble. This approach with the kit of parts allows us to rapidly assemble a proposal, and that it empowers early and effective stakeholder engagement. It allows us to work very close to real time with the same information in the engagement with the stakeholders that we're ultimately going to use to fabricate the building. So a change in the model at this point will be reflected further down the line, and it gives us a good quality control line. As is normal in a building information project, all of the coordination of the structure, the MEP and the architecture was completed in a federated model. But it was at this point that we started to realize how much more effective this process was using cross-laminated timber. The solid nature of the CLT panels makes the coordination of the builder's work openings much more straightforward. And again, using a rule set for openings generated by the specialist consultant gives us a much more robustly coordinated model. Similarly, the solid nature of the structure enabled robust performance analysis, whether that be thermal, acoustic or fire. And again, because there are no voids to consider or factor in, it will be interesting to see how this evolves now that embedded carbon calculators are becoming a much more important part of the decision-making process on projects at the early stage. So having completed the analysis and the three-dimensional spatial coordination within the BIM, it's a simple step to isolate the timber core in order to start the processing of that for fabrication. So that model, once isolated, can be digitally augmented with the cutting details and the element addresses required for the fabrication process. We've been able to make changes to the model all the way up to this point, but changes after this point can become more problematic and costly. That digital model is then used to drive the CNC machines, in this case at the KLH factory in Austria. The slot in the factory has been aligned to the construction program on site as close as possible to allow for a just-in-time delivery and to avoid storage and double handling of the units. The frame for this fairly large secondary school went through the factory in a matter of days, which was very exciting. The delivery logistics are developed using the model as well, to ensure that the right components are arriving at site at the right time. The load sheets are developed to ensure that the elements are in the right part of the lorry for when they're unloaded on site. And at Mayfield, there were 51 deliveries, 45 for the school building, 6 for the sports hall. And because the products are flat packed and the predefined panel widths are 3.5 meters, the loads are very efficient and there's very little wasted space on the lorries. Once on site, the assembly is very rapid indeed. From a health and safety point of view, it's a very safe site. At this point, there's only really the specialist subcontractor on site. It's a very controlled environment. There's little or no requirement for temporary works. For example, the balustrades and fall arrest systems are fitted to the external wall panels before they're lifted up into place. So they then generate a safe working platform for the next floor. On this project, the entire frame was erected in 12 weeks. Bearing in mind that the fabrication has been completed off the critical path, the frame can follow the groundworks immediately. So you can again see there's another advantage for the construction program. We talked earlier about the tolerances that can be achieved, and I think this photograph sort of shows that. You can see that the main contractor was able to procure windows and doors in advance of the frame being completed, confident that they were going to fit. And you can see the advantages in terms of air tightness and cold bridging, because there's very few gaps, and that solid wall construction behind it. Once the frame is in place, not only is the, a very large portion of the building complete, but the frame provides a very safe and robust working platform for the follow-on trades. A priority, however, is to waterproof the roof to protect the structure below as quickly as possible. Once that's done, it's a very comfortable working environment. So in terms of outcome, the ability to expose some of the timber adds warmth and a quality to what could be very everyday spaces, remembering that this is a state school built to a very tight DFE budget. And we're quite sure that this improves the learning environment. It's also worth pointing out that the exposed timber finish is exceptionally robust and hard wearing. And this provides means it's particularly well suited to stairwells and areas where there's potential of impact damage. And to conclude, I think Mayfield School demonstrates that by bringing together mass engineered timber and digital design, there's an opportunity to offer a bespoke, mass customized solution that addresses specific needs for a tight budget and avoids the need for a sort of generic solution. Thank you for listening.
Thank you, David. Fascinating project. With rather nice warm material when you actually see the timber. I believe there are 3 different grades in terms of what's visible.
Yes.
And you would select the highest grade for the areas that are to be exposed. And I think the only limitation on transport is actually the length of the panels in terms of what you can get on a standard trailer. Otherwise, you're into. So.
Yes, you're absolutely right. The width of the panels is sort of dictated by the width of the trailer, and the panels can be almost any length at all. So it's ultimately the length of the trailer that dictates that.
Yeah. Okay. I'm
But
sure we'll get a few. Sorry, I'm sure we'll get a few more questions. We're running about 5 minutes late, so we'll store up the questions for now. And I'd like to introduce our 3rd speaker for the morning. Gary Newman is the Chief Executive of Wood Knowledge Wales, which is a public public good member organisation. It's a bit of a mouthful to get around, Gary.
Yeah.
Which is focused on the transformation of Wales into a high-value forest nation. So Gary's topic today is obviously homegrown homes and how timber in the Welsh forests is actually being used. As per the other speakers, you'll find a more extensive bio in the chat box. So at this point, I'd like to hand over to Gary and hear what he has to say about the Welsh forests. Over to you, Gary. Thank you.
Thanks, Ken. We've just become a community benefit society, actually, which is a type of co-op that exists for the benefit of society rather than the members. So actually not hugely dissimilar from CIRIA. And on that, thanks, CIRIA, for the invite. It's lovely to be here. I'm just got to take control of the screen. There we are. John and David have set the scene really nicely for me, so thank you for that. There's no need for me to champion timber too much. My project or my talk is going to be on homegrown timber and why we should increasingly start to think about using timber from our own forests for the buildings that we build. And I suppose I'm going to tell my story through the Homegrown Homes project, which is a large multi-stakeholder project where we've just finished phase 1 and moving into phase 2. But before I start telling you about the project, I'll tell you a little bit about the context for the project and why it was conceived by us in the first place. Apologies for the Scots and the English. This has been focused on Wales, but the story is a little bit different in Scotland and England, but pretty much the same. That historically or in recent times, the public funding for grazing, for farming, has been way, way, way higher than for forestry. So it's little surprise that forestry hasn't really had the attention that it should, and that timber and the added value timber products are not currently readily available from the UK forest. The public funding, largely driven through the Common Agriculture Policy, has to be said, meant that there was very little incentive to shift a land use from farming to trees. That is now starting to change, thankfully. You know, a lot of people sort of quote this stat, but it's quite shocking when you think about it, that a little country like the UK is the 2nd largest importer of timber in the world after China. And, you know, is that a sustainable long-term strategic position? I would argue not, given climate change pressures that are creating all sorts of instabilities, all sorts of tree disease is now sweeping through the European forest. We've got ash dieback here, so we're losing ash. We've already lost larch. So and from a resilience perspective alone, we should be starting to think about getting more products from our own forest. But also there's an ethical dimension to it, and the UK has treated the world like it's kind of Tesco's Extra, and I think increasingly that isn't going to be a sustainable position. And with that, global demand for timber is forecast to treble by 2050. That's just tracking GDP growth forecast across the world. But actually, as we shift more and more away from fossil fuels to renewables, the demands on the forests are going to be even greater. And I would argue that the demand for timber is going to more than treble. So the question is, where's that wood going to come from? So in terms of Wales, only 15% of Wales is covered in trees. The European average is 37%. So I think England, it's about 11%, and Scotland, it's 18%. So Scotland's doing very well compared to Wales and England, but not so well compared to the typical European country. But despite that, the forests that we do have produce a surprisingly large amount of timber. They're incredibly productive. And the Welsh forest, despite the lack of it, produces enough timber for one timber frame home every 4 minutes. I won't go into how we've calculated that, but that means that we could build all the current houses that are built annually in Wales. We could grow the timber for that in about 8 days. And meet our forecast of need, which is about 8,000 homes in under 4 weeks. So we do have timber. It is there. We just don't produce enough of it. And we don't add value to our wood. So we focus on relatively low value markets with only about 4% of the Welsh timber going into construction. Construction being the optimum use for timber. Not only is it the highest added value use, but it also stores the carbon, locks the carbon away for longer. So this is quite a frightening stat, that over the next 40 years, the world is expected to build the equivalent of Paris every single week. Now, we have to meet our net zero carbon commitments whilst building a Paris every week. And just think of all the steel and cement that will be going into that kind of level of construction globally. It's huge, and we've already seen the stat from, I think, John's presentation of how much global carbon emissions are due to steel and cement. So we have to massively reduce our embodied carbon. The thing about embodied carbon, it's released to the atmosphere now, so it's hugely important. So I was quite disappointed when John was saying that it's not a part of the future home standard, because it's critical. It's not about future carbon emissions, it's emissions now that are the problem, given the time frame we're on to stay under 1.5 degrees. So I think that's a massive missed opportunity. And let's be honest, wood is the only advanced industrial material available at scale that can solve this problem. Yes, we can develop low carbon steel. It doesn't really exist on any scale at the moment. Yes, we can reduce the carbon emissions from cement up to a point, but those technologies are not available. They're a bit like carbon capture and storage. You know, they're not here for deployment today. Timber is, and I think it's really important that we remember that. So wood, if you're not from the timber industry, you might think of it as an old traditional material. But I love this quote. Stora Enso, being the one of the biggest forest products companies in the world, say that 70% of their sales revenue of the company is from products it did not make 10 years ago. So it's not simply bits of 4x2 or sheets of paper. It's packaging, it's biocomposites, it's biochemicals, and it's exciting new construction materials. And you've heard a bit about CLT, so I don't need to dwell on that. But, you know, low rise, medium rise, possibly even high rise enables steel and cement to be displaced. Then we have natural insulations that can help us move away from petrochemical plastics, and modified timber products, although this isn't grown in the UK. Accoya is a chemically modified timber that makes it hydrophobic, which makes it incredibly stable. They're not only available in solid wood, but also in MDF, which they now guarantee 50-year life in external environments, which is quite staggering, and it's non-toxic as well, so it can just go straight back into the circular economy timber recycling supply chain. So all sorts of new and exciting things possible with wood. Now, so just a little bit about Wood Knowledge Wales. As I said right at the beginning, we're a community benefit society, a type of co-op. Our vision is Wales as a thriving, socially just, zero carbon, high value forest nation. We're certainly not currently a forest nation. We're a sheep, beef and dairy nation. We have 9 million sheep in Wales, 3 million people, and they're incredibly environmentally damaging and entirely dependent on subsidy for maintaining them, whereas forestry is actually economically viable enterprise. But it's a big cultural shift in terms of land use. We're also a steel nation. You know, Port Talbot Steelworks, we identify with the heavy industries. And, you know, timber hasn't even really been considered an industry in Wales until recently, and I'll come to that. So our work is really focused on supporting the development of Wales forest industries, but not in a representative body way, in a way that meets the needs of future society, which is quite a challenge to the timber industry, as well as it is to sheep, beef and dairy and steel. So what do we do? So we tend to drive innovation through the collaboration, which I'll come to in a minute, up and down and across the supply chain. We focus on knowledge creation and exchange, very much like CIRIA. Political advocacy as well, to influence government decisions, and on occasion we get our hands dirty at the coalface if nobody else is prepared to do things or doesn't see the economic potential. So this is our membership. A lot of these names won't be familiar to most of you. A lot of them are Welsh-based, not all. But most of the housing associations are members of Wood Knowledge Wales, and they're the driver, if you like, for the Homegrown Homes project. They're the driver to change because they're top of the food chain, so they will specify timber, they'll specify homegrown timber, and they're very much supporting us on this journey. And housing associations build 1 out of every 3 new homes in Wales, so in the Welsh context, they're highly significant. Then we've got the timber frame manufacturers. I think all of them are members. Some names, some of those might be familiar to you, like Lowfield Timber Frame. And then architects, sawmills, product manufacturers and suppliers, not all in Wales, has to be said. Wales is seen as a market for some of these products for some of our members and want to get involved. And then forest management companies as well. So everything from the forest through to the finished home are involved. We don't need to dwell on our team, so I'll skip over that. Our kind of organizing Venn diagram, if you like, our organizing way of looking at it is to stimulate low carbon markets, so work very much at the sort of market end, and then try to encourage location and development of manufacturing, processing sector gearing towards supplying timber for construction because they're traditionally not, and then the growing of the types of trees and the management, typically importantly the silvicultural management of those trees so that they produce the kind of timber that we need. And then all of that needs to be supported by a wood culture that understands productive forestry, that understands that trees need to be cut down. And we haven't really got that in the UK at the moment. So I think forestry is really poorly understood. So our guiding question in the Homegrown Homes project was, how can the Welsh timber supply chain be transformed to deliver zero carbon homes affordably at scale? The sort of policy environment that we drew upon to communicate the importance of this was the low carbon agenda. So growing trees, everybody knows that is a climate change mitigation opportunity, and so is the use of timber, and that's less well known, but equally well supported by the big climate change UKCCC and UNFCCC. The people that say what we should be doing and setting targets are very encouraging of the shift towards timber in construction. Off-site manufacturing, as you've heard, is a key agenda across England, Scotland and Wales. And the foundational economy, you might not have heard of that agenda. That's very much about how you or where you focus your economic attention. And the foundational economy is encouraging a focus on those aspects of the economy that improve people's lives. That's food, housing, health, education, infrastructure. It's about 50% of Welsh GDP. The other 50% being the more the typical things that get policy attention, such as British Volt or anything else like that, that may or may not succeed, but only benefit the people working in the factory and around the factory, whereas the foundational economy activities benefit everybody because it improves their lives. And timber is very much part of the foundational economy, from employment in rural areas in terms of forest management, timber processing, and then the production of people's homes. We very much focused our research on the development of case studies. From those case studies, we drew out learning, we put on events, and then we created guidance. And I'll just, and the case studies are on a Google case study map. I think Susan from CIRIA will put something in the chat, put a link in the chat to help you find where all this information is. We created a low carbon or net zero carbon infographic and the role that timber can play in achieving net zero carbon, from embodied carbon reduction, minimizing energy demand through a high performance fabric, only using renewable energy, addressing the performance gap through things like offsite construction, measurement, post-completion monitoring, that kind of stuff, and offsetting to below zero. Forestry is a well-established means of offsetting. We also think that carbon storage in the built environment can be developed, and we're working hard to see that become a thing. So drawing to some kind of a conclusion, I just take you quickly through the outputs. So we produced 3 specification guides. Timber cladding, changing the external skin of a building is one of the best ways to reduce embodied carbon, so moving to timber. Wooden windows, the Welsh Government actually pays for about 70,000 plastic windows to go to landfill every year through their social housing refurbishment grants and new build, and that seems to me to be wholly unsustainable. So we need to move to timber windows. Equally, plastic insulants don't seem to be the right way to go. If you're championing the use of wood and then you're combining it with lots of plastic, I think that's disappointing. So we need to be moving to wood fiber insulation. No UK manufacturing at the moment, but I think that will change in the coming years. We produced embodied carbon guidance for housing associations so they can begin to understand it, measure it and reduce it. We produce building performance guidance, so how to understand, how to design, manufacture and prove that your buildings actually are low carbon, that actually are low energy and actually work. This was report was picked up by RIBA and endorsed by RIBA. We were very pleased about that. This was a report that we produced about how you could standardize timber frame, and I'll conclude on that one a little bit, so I won't talk any more about that. Housing associations, the economics of investing in forestry, how a carbon storage payment might work, be it an offset or payment from governments. This is our policy document for the Welsh Government, which they are embracing and adopting, which is very exciting. This was a report we produced in collaboration with TRADA, a sort of guide for newbies to timber frame, if you like, and where things go wrong from TRADA's experience of going to sites and understanding failure. And so that is a report that can help clients avoid those, and contractors. This is our foundational economy report, which is what role forestry and timber can play in supporting a net zero carbon improvement to people's, at the same time improving the quality of people's lives in Wales. And the final one there was our shot at trying to explain production forestry and timber to society. And just a final quick slide. So where are we at now in Wales? Now we've got to the end of the project, and So, or at least phase one, there's a substantial increase in financial support for forestry, and they're moving towards unblocking some of the regulatory barriers, which are many, to planting trees. Timber at last is being treated as an industrial material, and we have a timber industrial strategy under development. Social housing standards introduced last year were changed to encourage the use of timber, embodied carbon reduction and building performance. So the door's open with all the housing associations. They need to start taking account of these things. The people that produce the trees, most of the trees in Wales, or 50% of the conifers, let's say, to market, Natural Resources Wales, a bit like Forestry Commission, are committed to getting more social and environmental value from the timber they sell. So that means putting more of it into construction. And 11 local authorities and 6 housing associations, and that's all the stock holding local authorities in Wales, and about a third of the housing associations are collaborating to create a standardised net zero carbon council house manufactured off-site in Wales from homegrown timber. So that's a diffuse manufacturing base, but making a standardised product. So as a key mechanism to ensure quality and maintaining costs as low as possible. Thanks very much, Ken, and thanks for listening. Sorry if I overrun a bit.
Nope, that's bang on the what we asked you to do, Gary. That's a very, very impressive array of reports output from the project. We'll have to make sure that there's a link in the chat box to take people to your website so they can actually have a look at some of those. It's the statistic about building a Paris every week actually frightens me from a resources point of view. How can you manage reduce CO2 when you're building a massive, potentially massive urban area every week, in effect? And some of the stats, I think, CO2 emissions, cement production and use accounts for 8% worldwide. The majority of it actually in China, and that compares with 2.1% from the air industry, from airlines flying around. So if we can reduce the reliance on cement and switch to timber, it'll make a huge difference. Right, thank you very much. I'm now going to pass on to Gary. We've heard Gary Ryan from QBE. We've heard about the benefits. We've heard about the potential for carbon reduction, but there are some inherent risks. Advantages and disadvantages very, very similar to what David spoke about. So Gary is a construction insurance risk management specialist. And as with the previous speakers, we put a more fulsome bio into the chat box for you to have a look at. So at this point in time, we are running about 5 minutes late, Gary, but I wouldn't worry too much about that. We'll just chop a few minutes off the Q&A session. So over to Gary. Sorry, over to Ryan. My apologies. Thanks very much, Gary. Yeah.
No, thank you very much. Yeah, I don't think I've been called Gary so many times before, but yeah, there's a new one. Yeah, so thank you very much for today. Yeah, so I'm Ryan Jones, Senior Risk Manager at QBE Insurance within the European division. I've been in insurance quite a number of years now. Prior to that, I was in construction itself for about 10 years. That's both in managerial and trade positions, principal contractor, subcontractor. Yeah, and then I moved over to the dark side about 6 years ago and ended up in insurance. So yeah, it's great to meet you all. Hopefully the presentation will provide you with some useful insights to the risks that we see in terms of construction insurance, timber frame, mass timber, major builds, and then I've also included kind of some of the controls as well and best practice that we see. So yeah, hopefully today will help and we'll start going through it. Okay, just as a brief introduction to QBE in case anybody doesn't kind of know who we are. So we're a large insurance carrier. We've got offices worldwide. We've got a large presence in the UK construction market. I'm one of the senior risk engineers. My role's basically solely construction. And I've got quite a number of colleagues that are in the same departments as well. We've got some in the casualty side that also come into the construction part. We cover construction in all lines. So we do the CIRIA, which is your contractors all risks. And that's on your annual clients. We also do some project-based policies as well. So we have some of the largest contracts worldwide that we're involved in as well. Along with this, we've got other major lines of business as well, including your employees' liability, products, and your public as well as professional indemnity and motor. We currently hold many of the cross-class insurance programs for some of the largest contractors in the UK. We've got specialist underwriters that manage all of these accounts. So my role kind of comes in place once they've put all the policies in place, or pre-inception as well. We get involved and kind of analyse the risks from there. So in terms of some of the challenges that we see in construction itself, so like I said, we meet a lot of different clients. So we'll briefly touch on some of these challenges that we're finding in general construction. So firstly, if we go into the SG side, so we're no longer just seeing the building types and methods that we used to, bread and butter as such. Similar to cars, so we know the ins and outs of combustion engines, petrol, diesel, but now for environmental purposes and other purposes, there's a push towards electric and potentially hydrogen in future. It's all quite new to us. Where things that are new, there's quite a reliance on change and adaptation. And where there's change, there's always a challenge. This will always come with some reluctance until it's proven to be a good solution and good alternative method, until we properly understand these different methods. But with trial and error, there comes risk. And where there's risk, there's obviously hesitance. Nobody particularly likes being the guinea pig. That's in terms of insurance, construction, anything really. For years gone by, you know, we've referred to timber as a material that we used to make fires, not necessarily the structural members on the major buildings. So things are changing, but where there's change, we've got to understand it as well. So in terms of other countries abroad, you know, they're far more experienced than we are in terms of these larger scales buildings on timber frame, and they build very differently than we do over here. However, you know, we've got the drive for environmental impact reduction. You know, this has now pushed us to use more timber and alternative methods, and rightly so. We've just gone over parts of that in terms of the emissions. So rather than the high emission but proven techniques of non-combustible, such as, you know, your concrete, your bricks, your blocks, your steel, we've got to look at these alternative methods. So ESG, you know, for sure, it's definitely one of the major challenges going forward for the industry to meet. Then we move on in terms of material shortage and demand. So, you know, the few years has definitely been a wake-up call for the industry. So first we were hit with the impacts and aftermath of Brexit, which we're still seeing today. There's definitely been some impacts, put it that way. Material price influx, significant transport delays, in many cases materials and deliveries, they seem like they've gone missing sometimes for a week. That's seeming to get sorted, but again, things are a new normal. I think that's what they called it. Then we had COVID, so COVID hit, and then it had major effects then on production, material availability, as well as overall lifestyles and changes in terms of working patterns. Overall, it had a major change and it had a bit of a shock to the world. And then we had the awful circumstances within the Ukraine then, with the effects from that. You know, this has had further significant impacts on construction worldwide, and again created material shortages, which became even more prevalent. All of these, they've basically had a significant impact on availability of materials, cost of materials, a lot of uncertainty overall. It's now where we're beginning to see some stability and a new normality. But again, we've just seen the impacts of what's happened. So there's a lot of uncertainty, but we have learned a lot of lessons. So from there, we've got about fixed price contracts. So that's quite an interesting one, really. So pre-pandemic, there was in particular a lot of fixed price projects. So this links quite heavily in terms of material demand and pricing. So what we're seeing from insurance perspectives and conversations with our clients in the wider market It's the struggles that the industry have been having in terms of those fixed price contracts, prices that were agreed pre-pandemic and pre the further issues that we've had in terms of the economic crisis. So your prices of materials, your steel, your timber, they've all significantly increased. So where the prices initially were fixed beforehand, we're now having a big issue sourcing those materials, and it's putting many construction companies in serious jeopardy. On the back of that as well is your labour prices increasing. So again, a lot of increases overall, which have impacts on construction projects. So it's something that we still see. These fixed price contracts are still out there. They're still, they're still happening. Although there are many contractors now that are steering clear. But where there's opportunity, there's risk as well. They still present there's still quite tough times at the moment, even though things are calming a bit. But there's still a major risk to taking these type of contracts on. So from the nicely leads in then in terms of the skilled labours. So on the back of Brexit which was probably the key driver really. The UK lost quite a lot of its workforce, as many operatives returned back to various countries across the world. This has had a major impact on the industry, lost quite a lot of skilled labour, and we're continuing to struggle with that now. One of the other key drivers is the youth workforce. Construction, for whatever reason, doesn't seem as appealing anymore from a school perspective. So it's about how do we look at that? How do we bring the young ones through the education system and into construction to protect construction long term? So the long term effects of this at the moment, they're still yet to come. So hopefully we can start looking into this and get people into the industry, particularly areas such as London, where the workforce has been really heavily impacted. It's important to make sure that this workforce is replaced and the industry attracts new talent. So the skilled labour isn't just on site, it's off site as well. So you've got the off site frame assemblies. Again, it's something that's, in terms of labour, it can be quite scarce. So we really need to bring in these skilled experts, provide the training that's required, so then we can all have a greater understanding. And in terms of an insurance perspective, we'll see these as better quality risks with having those trained experts there. The problem that we've got at the moment is that there is a big shortage in skilled labour. So overall, though, in terms of what we need is a greater understanding, we need greater training, and we need to build attractiveness and appeal into the industry that's on-site and off-site construction. That'll be critical then to the UK infrastructure. So from then, we lead on to the supplier risks. So yeah, in recent times, again, to reiterate all of the economic crisis that we've had, supplier risks are becoming quite a major issue. So where we've got, say, one supplier from X, if there is no backup plan, and what we have found is that material prices are increasing, in many cases that supplier is going bust. They're literally ceasing business. The issue that we've got then is the impacts on the projects that are outstanding. So it's something that needs to be heavily considered. Again, it's heavily linked to the economic crisis and the monetary struggles that they've had. Many materials came from Ukraine. It's probably more than what we realised, put it that way. Again, these have all had a major impact in terms of sourcing and pricing of materials. To mitigate this, you can look at things like business continuity plans. They're very effective. Having various suppliers rather than single suppliers, each having capacity then to produce more of whatever material it is that's required to cover in the event that another supplier goes under or being no longer operational. So backup plan as such. And finally, we have the unstable material prices. So we've heavily just touched on this. It fully links back into everything that we've just mentioned. So therefore, your forecasting, your in-depth analysis your material prices. That's critical. Okay, so we move on to the construction insurance challenges as such. So what we are seeing, and this is everybody, we're seeing that ambitious architecture. I think that's one way of putting it. I'm sure we've all seen it. We've either spoke to the architects directly, or we've seen some of these plans to make the world a better place, a different place. All of these brand new, lovely buildings, new materials, new methods. Some with focus on ESG, and others simply for aesthetic appeal. Other times to suit the surrounding environment and the surrounding areas. Some of which are probably eye-catching. It's one way of putting it. The plans, they're different. They're definitely a challenge now, not just for the contractors, but also for the insurance in the background. As insurance companies, we generally steer clear of speculative risks. However, the boundaries that we're seeing at the moment are definitely being pushed by the architects and engineers, all with the aim to make better places. The issue we've got is that there's a big, probably case of unknown. There's something new, something different. We're no longer looking at a brick, block, concrete, steel that we used to. No longer materials solely being used in the same way that we're used to them being used. No longer low-rise timber or timber frame housing that we're used to. We're now looking at mass timber, larger structures. So the boundaries now are being well and truly pushed. And these aren't just one-off projects either. They're coming in more and more often. So things at the moment are definitely interesting. For mass timber, these can present quite they can be very difficult for us to assess in terms of insurance, especially as these are few and far between. There's a lot of unknowns. The claims data and experience can often drive insurance views and understanding of risks. However, in this case, when the buildings are quite minimal, it's not as easy to analyze. So there's a lot of skepticism. The key here is to ensure that the architects are working in full consultation with the principal contractors and the specialists and the engineers. So it's not just for aesthetic purposes, but they understand what the specialists say. So if there's certain materials, methods, and techniques that have been experienced in use and it's not necessarily worked or they've presented high risk, can those parties assist the architects with suggesting alternative methods without taking the responsibility of being the designer?
Hi Ryan, it's a few minutes after 12, so I'd ask you to speed up just a little bit. So
yeah, no problem.
We do get a bit of time for questions. Thanks.
Yeah, no problem. Yeah, so we're going to move on quickly then. In fact, can I move back one there? Yeah, sorry. So in terms of the escape of water losses, so that's quite high frequency, and the severity at the moment is completely unknown. Really, it's altering all of the time. In many cases, we're seeing up to like 8-digit losses. These don't make the media because they don't affect lives. It's very rarely that there's an internal leak that affects lives. So fire's always going to rightly be the number one there. In regards to timber frame buildings or timber buildings, water can have major damage, as the timber can be subject to rotting when it's moist or left unattended to. In the UK, we're far more likely to experience rain and wet conditions. That's during transport, delivery, assembly, installation. The risk is quite high. I mean, you can tell I live in the north, so it's more likely to be raining than it is to be dry. Design and control, it's critical to ensuring that the timber is managed correctly. The most important element is probably understanding of the timber by all parties. So the installation contractors, the principal contractors, architects, etc. And having plans to address the issue and concern at the earliest possible stage and provide training if required. Timber that has been retrofit on site or openings, retrofit, extensive and complex drainage specifications, they can all create further issues, all of which, they can impact on the sealed timber as such from when it's been delivered and expose it to vulnerable elements. So the best thing there is, you speak to the specialist, listen to the recommendations and base the designs and management on that. In terms of fire, water, yeah, so again, fire is always the number one. You know, does it burn? It does burn, but there's ways that you can help to manage to reduce the risk. So in terms of the key control, again, it's all about experience and understanding by all of the relevant parties. Speak to those specialists. So in terms of reinstatement costs, so from an insurance point of view, we see high reinstatement. It's far more expensive to reinstate something than it is to get it right the first time. The materials, what they were at one date to replacement date, they do heavily influx, and that is one thing that we are seeing quite heavily at the moment, and that'll include time delays, material costs, labour costs, and additional costs. The final one on this is just about the losses during transit and off-site storage and delivery. So what we're seeing in particular in, say, off-site modules is when they're being delivered to site, quite often one of the common losses is in the lifting activities. So incorrect lifting or poor supports creates kind of a crushing effect. So then damages to those modules then occur. So again, it's all about quality control and protections for this.
Yeah, that's
So
just gone 12:05. So if you could summarise, Ryan, please. So
yeah,
we
no
can then
problem.
move on. Yeah.
Yeah, no problem. Yeah, so your main risks in terms of the timber buildings as such, you're talking about your fire. So it's obviously about your fire spread, your voids where they can create a chimney effect, water which can affect your structural values, and then your moisture side of it as well. So your fire management plans. So what's key at the moment is this new JCOP that's been released. There is a link that's in the presentation as well. This heavily needs to be considered. We're discussing this with contractors at all the time now, and it contains things like your fire watch periods, temporary accommodation, some other major changes. So all different things that really need to be considered. And on the water side, then you've got the CIRIA management plan for your water management. So I'm part of the CIRIA group as well. So we've developed this template plan. It is in use by a lot of contractors, and to be honest, it is a very good document. So that this contains your control measures. So what you need to consider is your permanent and your temporary systems, and then your controls that you're going to put in place. From there, then you've got your moisture control plans. So your moisture control plans, particularly on timber when it's being delivered to site. So how is it going to be managed? Whether that be moisture monitoring, and again, speak to the specialists about this. What you need to make sure is that it's being covered at all stage, from the off-site to delivery to installation. How long is that timber going to be exposed? Can we get the envelope on, so all of your walls and your roof, as early as possible to reduce the effects then on the timber? And consider things like your leak detection as well. It's all best practice. Additional bits of best practice there. So you've got your SDA guidance on the 16 steps. Other parts where you can consider about incline roofs. Again, speak to the specialists on that. But we're finding that, especially on these mass timber buildings, ideally it'd be incline roofs. But these are conversations which you'd have to have with the architects. You know, they do like flat roofs, especially in terms of city centres. But again, at all times, speak to the specialist and try and recommend inclines. Where you can, eliminate hot works or reduce them. Off-site storage of materials, combustibles. So basically, do you need those materials on site at that time, or can they literally be last-minute deliveries, which is often best case. Your robust security measures as well. So remember that the main risk in terms of security quite often is kids getting onto site. That's usually what happens. Those are mostly unauthorized access, but also to consider, you know, about arsonists and people intentionally going to cause damage. Other parts are about your waterproofing as well, and your waste management controls. So there's just some resources there. So apologies for that. We've kind of flew through it quite quickly, but obviously we're trying to be mindful of time.
That's great, Ryan. Thanks very much for just speeding up that little bit at the end.
No problem.
I think we'll possibly come back to a lot of this. There's quite a bit in there. We've put the links to the various codes of practice and other documents that Ryan has mentioned actually into the chat box if anyone wants to actually go and have a look for them. I think what we probably need to do is give the insurance side of things a bit more time just to go into some of these things in a little more detail, but that's great. That's given us a flavour, and it's a counterbalance to what the other speakers have obviously done this morning. So what I'd like to do now is actually ask all the speakers to switch their cameras back on and their microphones, and we'll look at the questions. The first one that we have in the chat box, which has got a bit of support here, is there a difference in design life of timber versus a masonry house? John, would you like to field that one
first?
I'll
take that one. Thank you. Yeah, good question, Faye. Short answer is no. There's not. I think main answer to this point, some of the oldest houses in the UK and in the world are actually timber houses. So no, there isn't a risk. There isn't a difference between design life and picking up on some of Ryan's points that came behind that. Yes, yes, the key thing is keeping timber dry, for example. And actually, the thing that really rots timber is excessive drying and wetting and drying and wetting. So, so long as the right controls are in place, which are easily achievable with standard work in the UK and abroad, then timber frame houses will last. You know, they're designed life like most design houses for 60 years, will last well over hundreds of years.
Yeah, I think all you have to do is look around the UK, the remains of the medieval buildings, which were all cruck frame.
Yeah.
And I mean, they're well over 100 years old.
Hundreds of years old, yeah.
Yes, I don't know what the oldest one in the country is. And it's a fascinating, if anybody who's interested should have a look at the Forbidden City in China. It was actually built using a timber frame system. And the Chinese had actually developed a process for actually prefabricating members and joining them without having to use nails.
Yeah.
Which is a little bit like CLT as well, David, because I think there's a mortise and tenon approach to some of the way the panels actually go together.
Yeah.
We have a follow-up question then. Does anyone else want to pick up on that? Is there a difference of timber to masonry?
I think that there can be sometimes be perceived as being a difference. So from a marketing point of view, there's something that sometimes needs to be addressed around that.
There was a fairly damaging documentary a number of years ago. John possibly remembers it, I think.
Indeed, World in Action, yeah.
Yeah, World in Action, where a very small residential scheme of maybe only 6 or 7 houses was slated, shall we say, because of poor construction, and that tainted the people's views for a long time. Yeah.
Yeah, no, it certainly does. I think you're right, David. In terms of people's perception, I think there is certainly a perception out there. I know with some of the national house builders we work with, when we started Timber Frame, we did an awful lot of work to get their sales teams and stuff ready for questions. Actually, the questions never came. It was very limited, the number of questions that the public came to, and actually more and more now people are quite interested to know that living in a timber house that's got better sustainability and environmental credentials. So yeah, there was that. And then last one, on your point, Ken, yes, there was a World in Action programme that had a big impact on timber frame in the late 70s, early 80s. And it was essentially about moisture control. It was actually about having vapour controls in too much places and mould growth inside the buildings, and not letting the timber breathe properly, which again is something that everything to build a home that we now do that just doesn't happen. So yeah, perception is a key one.
So that's something also that comes up a lot in the insurance industry, Ryan.
Yeah, I mean we're getting all sorts of questions at the moment. I think that's probably a fair way to put it.
So moisture and perception, and even I suppose if you're dealing with, say, funders, lenders, their perception of a timber building relative to a masonry building, as it were.
Yeah, it's completely dependent on the area. I mean, the things that we see is literally worldwide. So yeah, the materials themselves, it depends on the area and how they're being managed. But yeah, there's all sorts of risks that are associated. Yeah,
we've got an interesting question just come in, which is actually about I think it must be from an architect, because it's looking at professional indemnity policies. Insurers have unreasonably started to insert a fire exclusion clause into the PI policies for timber frame manufacturers.
Yeah, I mean that's something I can't answer. I don't get involved in the
PI,
underwriting
yeah.
side, fortunately. So
Is the insurance industry prepared to better educate itself into this method of construction? Well, I think from what you described, you're obviously looking at the risks and moving on to actually look at that. Would that be correct?
yeah, I mean one fair way to put it is that, you know, a lot of these major projects that we're looking at, you know, they are being written by insurance companies. So a lot has changed in recent years. There's definitely a way of looking forward. Yeah.
Yeah, I think one thing I could add to that, maybe from the Structural Timber Association, so our industry sort of body predominantly for timber frame, but also looks at all uses of structural timber. We spent a lot of years working very closely with the wider insurance industry. We've actually got an insurance person involved in the board of the STA now. So yeah, it's all about exactly that point. It's around educating the insurance and helping the various insurers understand the risks, understand what we can do about them, and the mitigation we can put in place. So I think in answer to the question, most of the industry that I see from the insurance point of view are quite keen to understand it, because they see it coming as a potential solution. I mean, we're always going to have that building safety risk versus environmental thing to balance, and I think we're getting a good chance of balancing those off against each other to get the right answer.
Yeah.
From the point of view of CLT, I think there's an interesting sort of conversation going on around that, which there's lots of anecdotes about the idea that CLT chars rather than burns, and that it remains stable longer than a steel frame would in a fire. But I think what picking up on something Ryan said, what's missing at the moment is the data and the the sort of the track record. So because the technology's in its relative infancy in the UK, I think we kind of need to try harder to get that data, and whether that's around testing systems, establishing standard details, that sort of thing, that are pre-approved, that might help give people confidence. You know, so we're not just working with anecdotes, we're working with test results and confidence.
Yeah,
there's a lot of that work going on, I believe, funded in part through the Built by Nature organization, but I think War Thistleton have had some funding to create standard approved details for CLT. But I mean, it's a real big challenge that needs, I think, government to step in, because if we're going to innovate rapidly to net zero, we're going to be doing things that insurers have no knowledge of or very little knowledge of. And so there's a systemic challenge. I mean, the post-Grenfell tragedy there was no wood involved in Grenfell Tower, but the fear of fire is heightened.
The change of regulations,
yeah, and that's led to, you know, no timber in external skin of low-rise buildings in London. It's put up insurances in timber frame care homes that have been built for the last 20-30 years, you know. So it's a fundamental challenge that we need to get to grips with.
It does feel as though the really big issue is this balance between building safety or perceived building safety and sustainability, and we've got to navigate that, and the way to do that is through testing and data, isn't it, rather than just sort of ruling out whole material types.
Yeah, I think Trada did some research when after the major fire in Nottingham at Nottingham University, when the laboratory building was built, it was burned down a few weeks before it was due to be handed over. And they looked at the frame, and the timber, I think it was a glulam frame, which stood for about 12 hours, whereas with the temperatures, they found that a steel frame would have been down within about an hour. It would have melted. So there is some data, but not a great deal. And I believe that Cambridge University was looking into the fire performance of cross-laminated timber, but I've never seen the results from that. We've got another question on CLT, David. How does mass-engineered timber compare to standard timber from a carbon perspective?
Oh, I'm not sure if I can answer that.
That's a tricky one. We probably don't have the metrics. I don't think John will. Obviously, you're looking at the timber frame. It's something. I don't know if anyone will have the metrics for that one.
I mean, there's more sequestered carbon in it, but there's more of it.
Yes.
Yes. Yes. Yeah. Yeah, I was going to say, I was looking at that. I'm not sure how we answer that in terms of how we compare those in terms of overall benefit or comparison. To be fair, I'm not sure how we do that.
We did have a question, I think, which was related to Gary's last slide. Obviously, going through what's been implemented in Wales, and asking how it could actually be implemented nationwide. And you've typed an answer, but I think the key there, Gary, is I think what you said recently is it needs government impetus and support. Would that be right?
Yeah, totally. It does really. So we're an independent organisation, and we can do. There's a lot of things that we're doing that I haven't talked about that we're able to do through our self-funding routes. But it's not all about money. I think money is a key part of it, but you need to get everybody on board and explain what they have to gain and create communities of practice that you do in CIRIA, that we do in Wood Knowledge Wales. It's a constant communication piece. So it's a lot of work, and that costs money, and you need the policymakers to buy into it. I mean, we started without any government backing for it. And it was only after we started that they came on board and thought, you know what, this looks really good. This solves a number of our problems. We've also got in Wales, we've got the climate change ministry, and within that we've got the built environment and the natural environment. So it's all in one ministry. If you look at Westminster, I think you'll find that the ministries that you need to get behind something like this are in about four or five different ministries. So we have a big advantage. Oh, we have a stable government as well, although it doesn't have full devolution. There's quite a stable political consensus in Wales, which makes long-term policy stuff easier as well.
So do we need to bring all the organisations like the STA and TRADA and possibly Wood Knowledge Wales, and whether they might well be in the long term a CLT association of some kind, get them all around the table, all considering the various issues that come up, collaborating, sharing ideas, and not being precious about intellectual property right, perhaps, but that makes it even more difficult. Ryan, I've got another. Yeah, sorry. Yeah.
Sorry, yeah, that's part of it, but you need to bring in the clients and the architects and the local authorities as well. Otherwise, it looks like a lobby position. What we're championing in Wood Knowledge Wales is environmental change. So we're not coming at this from a trade body perspective. Not that there's anything wrong with trade bodies, but that's not what we are. And I think there's a key difference there.
We maybe need a timber constructions conference somewhere in the UK. I think they're beginning to occur overseas. Ryan, another question for you, which relates to one of your earlier slides, is how can we combat labour shortages in the industry?
Yeah, so again, that more reiterates in terms of probably the educational system. I think we've got to be bringing apprentices through. And that's in all trades really. So you're talking about your actual site trades, and then about your management side, about your surveyors, etc. So it's probably more towards maybe presentations at school. Get that more appealing, get the message passed on at the school level, at college level, university level. There's a lot of major contracts out there now that are pushing these type of schemes, and I think as long as you know, we can progress with that. It'll help protect the industry there as well.
That's great, thanks.
Could I add something?
Sorry, yep, David.
To that, well, it's two immediate thoughts. One was move more things off-site, so that that there's a labour force working on them repeatedly and moving away from transient labour on site. And then picking up on Ryan's point, that there's a communication problem that needs to be overcome within the industry, which is that much of what happens now in construction is really it's digitally driven. It's really quite exciting. But we have a problem communicating that somehow. We're still sort of stuck in a perception of a sort of, you know, muddy building sites, whereas in fact most of them are, you know, are powered by technology and the things that younger people would get very excited about.
Yeah, I think that's a good point, Dave. I think we're a similar place from. I was going to say the same thing. Move so more stuff off site, and with investment, you know, that we, for example, what we're doing in the factory, we've had factories for, as I was saying, like 40+ years, generally full with young fit men, because it's manual labour and it's a lot of hard work. You know, we're actively recruiting now for a much more diverse workforce, because what we need is people to maintain robots and machine lines. Yeah. There is no manual handler, there isn't stuff, and we can attract a much more diverse workforce to work in the factory as well, grow that, and it's and on site, exactly your point. You know, all our guys on sites now don't have paper. They're hardly any use paper. They're all on iPhones and iPads. Yep. And all that things. But that view in schools of people working on site as a brickie in the mud with a trowel getting wet and cold.
Yeah.
Just, you know, it's much less of that. So I think there's loads of stuff as an industry, certainly as an off-site sector, that we can do to help some of that.
Yeah, the Game Boys and the PlayStation generation. So, and I think even they've been surpassed. I had one final question for Gary. It's possibly a closed question. Do we grow enough timber in the UK to currently to support the construction industry, or do we need to plant more? Just a brief answer before I do a resume.
Well, we do. I mean, all the wood that we grow and harvest and process is used in one application or another. But we do need to shift much more of it into construction and burn a lot less of it, to be frank. So making things like wood fiber insulation, stress grading more of the timber, maybe less timber decking, more timber structures. That kind of thing. So those you know, there've been market-driven decisions taken by the sawmills, but I think we need to start influencing that as a sector much more, so that much more flows into more socially beneficial applications.
Okay, that's great. I'd like to thank our speakers this morning. It's been fascinating, a wide range of topics, some excellent metrics on the carbon. I'm sure that this topic could be expanded even further. I'm actually of a mind to try and run a similar seminar again in a few months' time. But at this point, I'd like to hand over to Dirk to sum up and close things out.
Yes, thank you. Thank you very much, Ken, for expertly chairing this very insightful webinar. I think it's been great to have that honest and transparent discussion about the benefits as well as the disadvantages of the use of timber. But without a shadow of a doubt, I think we've proved today that it is the most renewable and sustainable material that our sector could use. And in maybe lots of ways, we need to keep being that advocate and that disciple, and gently pulling the horse to water, and with the help of the government agenda, which is definitely supporting modular and hopefully timber frame construction, we should get there. I'm conscious of the time, so I want to also obviously thank our four speakers who've been excellent. Thank you to the audience for participating and giving us some really good questions as well. I just want to finish by flagging up our next net zero carbon webinar, which is on the 6th of December. I'll just put a quick link into the chat so you can see on the 6th of December. Go onto our CIRIA website and you can register for that. I can't stress enough how interesting that's going to be in terms of sustainable resilience using precast concrete, Premier Modular and NG Bailey will provide some case studies around modular construction that has furthered the net zero carbon agenda, and the supply chain school, sustainability supply chain school, will also provide a really good case study. So do join us again on the 6th, and thank you for coming to this webinar today. Thank you again.